So now we'll talk about the big things when we're talking about trigonometry. All right, sine and cosine. All right, these are the ones get used the most. All right, so the definition. So we have this angle. And when we're talking about angles, we always start off with one side being that positive x-axis. So that side will always be there. And then we rotate, if we're talking about positive direction, we rotate this way to get the other part of our angle. All right, this other part, the kind of side we're rotating around, that's called the terminal side. Again, not really terminology you have to know, but just for the definition. All right, and as you can see, if I draw this line, this terminal side in any direction, it's going to hit the unit circle in exactly 1 point. All right, it's not possible to draw this line through the circle and hit more than 1 point. And that point's going to have an x value and a y value. And we just give these things name. That x value we call the cosine of what angle we're talking about. In this case, it's called theta. And the y value we just call the sine of whatever angle we're talking about. In this case, it's theta. So if I plug theta into the sine or cosine function, it's just giving me that x or y value. Right, one slightly confusing thing is that cosine's x and sine is y, even though we always say sine and cosine. So even though we say sine first most of the time, keep in mind it's the second value, the y value on the unit circle. So once we start talking about values of sine and cosine, sometimes we kind of don't think about the unit circle once we start memorizing values and stuff. I would always kind of keep this in mind in the back of your head that sine is a y value on the unit circle and cosine is an x value. That's going to help you kind of figure out what you're supposed to do in a lot of different applications of sine and cosine. All right, so now we want to figure out values of sine and cosine. What happens if I plug specific angles in? All right, when I was doing calculus, this is pretty much what I had memorized, what I wrote down on the top of every test or quiz I had to do. In trigonometry or in calculus class, I'll just write down this thing real quick. So I always had my sine and cosine values. Again, just so we can remember. All right, these are the same angles in degrees. Again, we're focusing on radians. All right, so it's the 30, 45, 60 are kind of the middle ones, 0, 90. The thing that can help you memorize this chart, if you have this chart memorized, you can get all the other stuff from just kind of inferring different things. All right, the 1/2, you can think about it as the square root of 1 over 2. All right, the square root of 1 is 1. So you can see you just have these square roots that increase by 1 each time. That can help you remember what the values are. And also, if I think about the unit circle, as this angle rotates, the y value, all right, as I kind of track along the circle, you can see my y value is getting bigger. So these numbers, as the angle gets bigger, these get bigger. It goes from 0 up to 1. Doing the same thing, you see my x value. This is the origin. My x value is slowly working backwards towards 0. So these numbers, as they go along, get smaller. All right, so sine gets bigger as you go up to pi 2. Cosine gets smaller. And that can help you remember that sine starts at 0 and cosine starts at 1. Another way to remember that is that this point is the point 1, 0. Because you just go right 1 on your unit circle. And the x value is 1, the y value is 0. So there's a bunch of different things that are all working together. But if you can kind of memorize this table and write this table down, we'll figure out how we can do everything else from just knowing these values. So one way you can just use that table to get other angles is using reference angles. So if I said, what is sine of pi over 3? You just look at your table, you know it's the square root of 3 over 2. But 2 pi over 3 is not in that table, so how can we figure out the value? All right, so we're going to use a reference angle, and this is where it's important to remember. Full circle is 2 pi. Half of a circle is pi. And because we're talking about the angle 2 pi over 3 with this 3 in the denominator, I'm just going to rewrite these as 6 pi over 3 and 3 pi over 3. And I'm doing this because the first thing I want to do when I'm thinking about this angle is I want to be able to draw the angle 2 pi over 3. That's going to help me figure out where it is and kind of infer things from that. So 2 pi over 3, where there's a 2 up here, 2 is a little less than 3. So 2 pi over 3 is going to be a little less than a half circle because it's a little less than 3 pi. So the angle is going to look something like this. I guess the half circle would get me to here. I'm a little bit less than that. All right, so this is the angle I care about, 2 pi over 3. And then I'm going to make something called a reference angle, which is the piece that I'm missing between that angle and the x-axis. So if I was in the third quadrant, I'll just do a quick example. If this angle is here, this would be the reference angle. If I was in the fourth quadrant, that would be the reference angle. So it's always the little angle between the angle that you drew and the x-axis. All right, in this case, let me just erase some of this. All right, in this case, this is my reference angle. It kind of completes the half circle. So if I went 2 pi over 3 in the green part, the white part that I haven't done yet to complete the half circle is just going to be pi over 3. All right, so I know my reference angle is pi over 3. Let me just redraw another circle using that reference angle. So now I'm going to think about pi over 3 as the important angle. And I know pi over 3 using my chart. The cosine of pi over 3 is actually not going to be important, but the cosine of pi over 3 ends up being 1/2. The sine is the square root of 3 over 2. How does this help me get the angle, or the point I actually care about? Well, if I just reflect this angle, if I just flip it over to go this way instead, then this becomes the pi over 3 reference angle. And we know this big angle is 2 pi over 3, the one we were looking for at the start. So I'm going to use the point that I have in my table to tell me what the point is over here. And what's the only difference between the point on the right and the point on the left is I just flipped it over the y-axis. So the x value is going to switch to a negative number. And the y value, I'm just going straight across, so the y value is going to stay the same. And again, sine of this angle 2 pi over 3 is the y value there is going to be the square root of 3 over 2. So the way some people would do this question is they just have the full unit circle memorized. That's memorizing a lot, and there's a lot of place for errors. But just by knowing the sine of pi over 3, I can figure out what the sine of 2 pi over 3 is by using the reference angle pi over 3. All right, so we'll do more practice with reference angles, but this is one way you can figure out the sine and cosine of an angle that's not on that chart. And the other way is using something called coterminal angles. So if I have this angle in my unit circle, let's just say it looks like this. This is my angle. If I add 2 pi to this angle, 2 pi is a full circle. So I add 2 pi to this angle is going to go all the way around the circle and end back right in the same place. And what happens with these two angles, they hit the same x and y value, which means they have the same sine and cosine. So coterminal angles, angles that differ by some 2 pi over 2, are going to have the same sine and cosine because they end up back on the same place on the unit circle. So I can do here 7 pi over 3. Just like I said in the last example, a full circle is 2 pi, which since I'm talking about over 3, I'm going to rewrite as 6 pi over 3. And a half circle is pi, which is 3 pi over 3. 7 pi over 3, with that 7 on the top, is bigger than 6, so this is more than a full circle. And for me, I always like to think about my angles as just being between 0 and 2 pi because it's that one picture, that one circle I have to worry about. So 7 pi over 3 is bigger than that. So what I can do is take 7 pi over 3. And that angle is too big, so what I can do is I can subtract 2 pi from it. And like we just saw with this picture over here, if 7 pi over 3, let's just say it ends up here. If I subtract 2 pi, I'm just going this way, 2 pi, and ending back up in the same place. So I'm really not changing the angle I'm talking about. It's going to be a slightly different number. So 7 pi over 3 minus 6 pi over 3 is pi over 3. So it turns out the 7 pi over 3 and the pi over 3 angle. Notice I haven't evaluated the cosine part yet. I just replaced this angle with a coterminal angle. All right, so those two angles are going to have the same cosine because they're on the exact same spot in the unit circle. And now I can just use my chart. Sometimes you have to use reference angles at some point. This one we just get lucky. We can use the chart, and our answer is 1/2. Right. So if the angle's bigger than 2 pi or negative, generally I just move it until where it is between 0 and 2 pi, and then do all my reference angle or using the chart type thing. And now real quick, all right, I'm going to go through these ones quicker just to kind of show how you would do these. 4 pi over 3. All right, 4 pi over 3 is a little bit bigger than pi over 3. So when I draw this picture, all right, 4 pi over 3 is going to be a little bit more than a half circle, a little bit more than 3 pi over 3. My reference angle, well, 3 pi over 3 gets me the half circle, so this little reference angle in here has to be pi over 3. I know the pi over 3 point up here. I have to reflect it twice. So I need to reflect over the y-axis first to get over here, and then reflect it over the x-axis next to get down here. All right, this makes your x value negative. Flipping it that way, this makes your y value negative. So this point up here is, let's see, 1/2 square root of 3 over 2. This point down here, both are negative, which means my sign of this is going to be negative square root of 3 over 2, because it's the y value of that point. All right, so that's using a reference angle just like we did before. Negative 5 pi over 6, I mentioned this when we were talking about coterminal angles. Generally for me, I just like to make them all positive, so I'll take negative 5 pi over 6 and add 2 pi to it. Again, that doesn't really, it changes the value of the angle, but it's still in the same place in terms of the unit circle. So this is going to be, if I want to get it over 6, it's going to be 12 pi over 6, and that is 7 pi over 6. All right, so negative 5 pi over 6 and 7 pi over 6 are the same, basically. So I can take the cosine of this instead. And then here, I'm going to do this one even quicker. All right, this one, 7 pi over 6 is a little more than 6 pi over 6, which would be half a circle. So it's going to be a little more than half a circle, all right, which means the reference angle that I care about is pi over 6. And if you look at your chart, you would see that the cosine of pi over 6 would be square root of 3 over 2, so this answer is going to be negative square root of 3 over 2. Right. Again, that's not going to be the answer every single time. It just happens to be for these two cases. All right, 15 pi over 4. 2 pi is 8 pi over 4, so this is an angle that's too big, so I'm going to subtract 2 pi from this. And 15 minus 8 is 7 pi over 4. And 7 pi over 4 is a little bit less than 8 pi over 4, so it's a little bit less than a full circle. So this is the angle I care about. My reference angle is this little angle in here, close to the x-axis. And that's going to end up being pi over 4, the little part that I would need to complete the full circle. And I know sine of pi over 4 is my reference angle, so my final answer is going to be negative square root of 2 over 2. Because when I go from up here to down there, my y value becomes negative. All right, that's a lot in one video: reference angles, coterminal angles, finding all these values. All right, but this is the main thing we're going to practice in class related to sine and cosine before we go on to the second half. All right, so kind of make sure you can kind of copy down that chart. Again, some people don't even need to do that part, but I always had to do that when I was in school, writing down that chart. And just having that chart, I can use pictures of angles and stuff to get all these values from there. All right, so that's a quick overview of how you find the values of sine and cosine for these different angles.